What's up, guys? This is Tampatec and this is the Getaway. I'm going to be working on this and hopefully we can get this up and running so it works 100%. So I'm going to lower the volume so you don't hear the audio because I don't want to get copyright flagged. So just to show you the mod, it works with the sound effects and everything. Isn't that cool? But let's go ahead and show you what's going on with the pinball machine. When you shoot the ball up the ramp, it doesn't go around the loop. Even though the light is lit, it should go around this loop right here. Supercharger ramp is not working. We're gonna check it out right now, and we're gonna enter supercharger. Ready? So, for some reason, enable that. So the coil's working, alright? Looks like the optics are working. They're recognizing right there. I don't think all of them are working though. So I don't think all the optics are working. Let's see if... Let's go to the switch test mode. Alright, ready? There's optic here. See, this optic right here is not working. And how about this one? This one's not working either. See, this one works. And this one works. And you got these switches work fine, but this is not working, and this one's not working. Here we go. So it looks like, oh, here it is. Opto ramp switch assembly. Down. Alright, so that's not it. This is the driver board. This is the power driver board. This is the CPU. I believe that's the Fliptronics. This is the soundboard. And this is for the DMD display. I don't see the optic board. You just pull this out, it should click. Oh. And it locks in. And then you lift it all the way up. Put this up, and that should hold it up. Alright, that's not going to work. I need to lift it higher. I'll make sure the balls don't fly out. This is for the light bulbs. Light bulbs. I think it's one of these two boards right here. Oh, it tells you there's it. Alright, so A13901, A13901. Alright, that's it. We're gonna check for loose connections. That's probably the most common issue, loose connections. I don't think it's a bad optic. They kind of last a long time. If anything, it's probably a loose connection, maybe cold solder joints on the circuit board. And I'm actually gonna, it's probably best, it does have a capacitor on it, and those capacitors only last around 10 years and they start to like swell and leak and have all issues. So it's probably best to take the board down, clean it up with fresh solder, and replace the capacitor. So that's what I'm going to do. And when I pull the board out, I see these burned resistors. So we're going to replace them, but we're going to test them before we replace them. So red. So the colors are red, brown, which is red is 2, and another red is 2, and then right here is the multiplier, and the gold is tolerance. So the multiplier is 0, brown is 0, so that's 1 0, and it tells you right here. This is the chart. So red. So here is the color chart for resistors, and as you can see right here, there's colors that are grouped together, and then there's one color band far away separated with the other ones, and the far away color band is the tolerance. Gold is 5% tolerance, so when you read it, you should read within 5% of its value. If it doesn't and it reads 7% of its value, then it's bad, and you replace the resistor. Even if the resistor doesn't look burned, replace it if it's anything over 5% of its value. Now right here, there's 4 color bands grouped together, and then there's a far away color band, and that is a brown one, and you see that's 1% tolerance. So if it's any higher than 1% tolerance of its value when you're reading it, then swap it out. Now red is the first color you would see, and right here, that's number 2. Red is 2. So that would be a number 2, and then green, right here is number 5, so that'll be 2 5 in the number, and orange is 3 zeros. That's the multiplier. So you have 3 zeros at the end of this number. So 2 5 with 3 zeros. So 25,000 ohms, and that's what that is. See? I don't know why they don't print just 25k ohms. Is beyond me. I mean, some resistors do, but I don't know why they still use this method. It's really stupid. All right, so here we go. I got these resistors that look bad. Let's go ahead and read them. And if they look burned, I would just replace them. But there's a reason why they're burning up. It could be this IC, diodes could do it. Usually not a capacitor. Could be a bad solenoid that does that. So we're gonna go ahead and try and see what's causing that issue. We're also gonna hit it up with some solder. It looks like it has bad solder joints right here and here. I don't know if you can see that. So I got my ohm meter right here, and let's go ahead and read that. That should be 220 ohms. That's pretty close. And we got 217 ohms, 218 ohms, and they all read pretty good. Let's replace them anyway. And this capacitor, we're going to read that. You have to read the capacitor out of circuit. Now that's going to be hard to remove because I don't know if I'm able to get that out. Okay, there it goes. Usually if there's very little solder, my solder sucker can't grab the hold of the solder and suck it out. But this is working so far. I want to replace this capacitor, but I don't have this value. So I got some 220 ohm, 1 watt, 1 tolerance resistors. It doesn't hurt to replace them, right? So I got 3 right here. When in doubt, change it out. It's just below, well, it's right around that. It's like border. So here is a reason to replace them. So let's go ahead and do that. There's no polarity, so I don't have to worry about that. Oops.
Well, I think it was facing this way. Yeah, this is a positive and negative, and there's an arrow pointing to the negative. So that does have polarity, so you have to make sure we put that in the correct way. But the resistors, there's no polarity. These are like borderline bad resistors. Capacitors are known to go bad over time, and this pinball machine is 30 years old, so. Up, negative. So the negative looks like it's this way. And this is 35 volts, 100 ohms. Reads good. It's reading 113. So this actually reads good, this capacitor. It's 35 volt, 100 microfarads, and it's reading 111 microfarads. Yeah. And then, see the arrows with the black arrows facing this way toward this terminal? That's the negative side. Alright, so let's check out the ESR, because just because the capacitance reads good, ESR could be bad. Alright, so this is 2.57, and I have to reference it according to 25 volt capacitor, but this is a 35 volt capacitor, which throws everything off. And so if it's a good capacitor if it's less than 292 microfarads. So this is actually bad according to the ESR meter. Yeah. So this has to be replaced. This is a 100 microfarads capacitor. And let me just show you this one. Connect that right there, and this one right here. And see, look, this one reads way lower, 0.1. So just to show you, so we do have to replace this capacitor. It is bad, even though my other meter reads good. So I want to find a way to replace that. All right, let's go ahead and solder these up. Alright, so let's go ahead and snip these legs. Snip, snips. I'm going to keep the resistor legs just in case I find a circuit that has a broken trace. Now this is a dual-sided board, and to solder a dual-sided board is a little tricky. I use this method. So right here, there's no solder right here and here. So what I do is I add a little bit extra solder, and then I drop it. And it brings it up closer. Or you can just solder it right here.
I only do that technique if there's a metal heat sink in the way, but since there isn't, I could just solder it from the top side.
And we can just solder that like that. Just drop it down. It should bring it all the way through. Didn't really, but it still looks like it has a connection, which is good. Everything else looks fairly good. You can read these diodes and see if they're reading good. So the silver stripe is the cathode negative. And we're reading, what are we reading? 0.5 is good. And that's good. Yeah, these are all good. That's a normal reading. Now, if it was reading lower than, let's say 0.1 or less than 0.1, then replace it. And then this should read OL. Open line, open line, open line, open line. Also could mean open loop or open line. Basically means the same thing. And then we have to look for that capacitor. I don't know if I have this one. All my capacitors, I only found one and the legs are too short. It's 50 volt, 100 farads, microfarads. That would work, but the problem is it's not going to reach the solder connections. So I'm probably going to have to extend them. So I do have some extensions right here, which I always keep just in case. So let's go ahead and do that. So I'm going to put these in and bend them just like that. Alright, and bend that this way. I'm going to add a little bit of flux right here. It's a cleaning agent, so it bonds better. Actually, I'm going to read this before I put it in. I should really definitely read this, because even if a capacitor sits on a shelf for like 5 to 10 years, it can go bad on a shelf. So let's go ahead and read that. And the stripe side is the negative. Let's go ahead and test that out. So it's reading 99 or 98. Alright, so it's reading 98, slightly low, not too bad. There is a tolerance on here. I think it's 10%. So if it was reading below 90 microfarads, then replace it. But it's 98, so we're good. Let's see if the ESR is reading good. And just replace the batteries on this, so it should be more accurate. Just in case, I'm going to calibrate it by hitting the 0 button. Alright, and hit the 0 button, calibrate it. Alright, so we're calibrated. And put the black lead on the stripe side and the positive lead on the positive side. And it looks like we got a very low ESR reading. It says good cap right here, it says it. Alright, so let's go ahead and remove this. We're going to use that, and we're going to check this one more time. See the arrows facing toward the negative? That's how I know it's the negative side. So this is 100 microfarads, this is 35 volt, this is 100 microfarads, 50 volt. You can go up on the voltage, it just means it can handle up to 50 volts before it swells up and blows up. This one can handle up to 35 volts. So this is definitely the right value and an upgrade. It can handle higher voltages passing through it. And this one, look at the ESR readings, a lot higher. It's 2.8. So, and it tells you right here, this is good if the capacitor is less than 22 microfarads. And this is 100 microfarads, so it's not less than 22 microfarads. If this was less than 22 microfarads, then it would be considered a good capacitor. But it's not. Okay. So let's go ahead and put this one together. So right here, the plus, right here is positive side. So we're gonna put the stripe side toward that opposite side. There we go. So I got them hooked in. And let's go ahead and solder that up. The flux really helps. It's magical stuff. And add a little bit more there. We're good. We are good. Alright. Let's go ahead and test it out and see what happens. So, alright, let's just play the game and see what happens. To launch the ball, by the way, you hit up on the shifter. Working, and the inverter works fine.
Now my Samsung cell phone has a feature where I can record in slow motion, and I thought you guys would appreciate this footage. The lights are flickering because there are LED lights. Incandescent lights I don't think flicker, but you can see how the ball rides on the outside of the ramp rail, and it jumps actually a gap right here. And I use Castro full synthetic oil to lube it up, make it go faster. It works great.
I don't know why it says there they are. Alright, so everything seems to be working. Okay. So far, so here in video mode. Oh, this is interesting. You have to use the flipper buttons to drive around. And then hit up on the shifter and drive faster. Crashed. So I'm using the flipper buttons right here to steer left, right, and then left. Going to test, and let's go ahead and check it out. There it is. The optic is working. Optic is working. So we're good.
Now, what I should have showed you guys earlier is how to check optics. But I'm going to go ahead and show you now. Better late than never. So on a TV remote, if you want to check the infrared sensor that sends a signal to the TV, you can basically use any TV remote and a digital camera and check the light. The human eye can't see this. Only a digital camera can capture infrared light. Look at that. So you know that the TV remote is working because you can see that infrared light. Now, if that's really, really dim, then you need to change out the batteries, or maybe you have a weak connection because maybe something spilt on the buttons, or maybe the battery's leaking or something like that. But these are strong infrared lights. So that's how you check a TV remote infrared light, or LEDs. And then right here, you can actually check the optics on a pinball machine too. So I'm going to go ahead and turn on the pinball machine. Make sure you have all the lights off in your room. So right now, all the lights are on right here. Let me go ahead and turn off the lights on the playfield. There's a special photo mode. When you press this button, it turns off the lights, and the pinball machine is on.
And see, the light is shining. You can actually see it from the side too. So if the ball breaks that light or breaks the beam, that sends a signal to the CPU saying, hey, the ball is passing through here, and it tells the diverter to close or open, which is kind of cool. And then there's also optics behind here letting the coils activate. So if the optic right here gets interrupted or the light breaks because of the ball, then the coil turns on for, I think, like 1 second and pushes the ball through. So there's magnetic coils that push and accelerate the ball all the way through. There's 3 of them. So there's 3 more optics and 3 more coils back there. And there's an optic over here too. Let me see if we can find that optic. Where is it? Should be around here somewhere. There it is. So there's that optic. It is working. And here's the other optic. So they're working. Now on the receiving end, I have it in diode mode. And you should get like about 1.1, 1.5 is fine. And I believe it reads the same either way. It doesn't matter. But you know, this is what I use. I use a digital multimeter, diode mode, and that seems to be fine. Guys, hopefully you learned a little bit about board repair. If you own a Getaway pinball machine, hopefully this video helped you out or will help you out in the future. And if you found this video informative, give me a big thumbs up. I'm going to produce a video on all the cool tech mods for the Getaway pinball machine. So subscribe and hit that bell notification to stay updated on the latest tech videos. Share this video to anyone that's into pinball machines or electronics. And if you guys are interested in the Getaway pinball machine, you can play that on your phone. I'll leave a link in the video description below. Just download the Williams Pinball app and you can play this on your phone.